So applications for inequalities is just working with word problems and using inequalities to solve word problems. So before we get into some examples, it just is really helpful to know what inequality goes with which phrase. So looking at what these are, if you want something that is under a certain amount, then think that expression needs to be less than a certain amount. This next one is at most something. Think about what that actually means, because a lot of students will see that at most and immediately think more than, because more than sounds like most. But if something is at most 15, for example, ask yourself the question, can that go over 15? If it can't go over that amount, then it needs to be less than or equal to. So in this case, if something is at most 10, the most it can be is 10. The rest of it could be less than. It could be a true answer if it's less than. So at most is going to use less than or equal to, and so is no more than, the phrase no more than. So don't get confused by seeing more than and thinking it needs to be greater than. Think about it in terms of asking yourself the question, can this value go bigger? If my number is larger than that one, does it still fit that? So no more than means it can't be any larger than whatever number it's comparing to. On the other side, for greater than, you're going to see words like exceeds. If something exceeds something else, you'd use greater than. If it is at least 10, that means the smallest it can be is 10, and it can go more than 10. So again, ask your question to yourself, can it be larger than that? Or can my number be smaller than whatever is there? And that'll help you pick the inequality. Another similar phrase is no less than. So note, these look like using the word less than, or the less than symbol, but note the symbol that you're actually using is greater than. So ask yourself those questions. Can it go larger than that number or smaller than that number? So actually applying it, in this example, the length of a rectangle is 6 times its width. If the perimeter is at most, so I'm going to underline that, there's where our inequality is going to go. If the perimeter is at most 154 centimeters, what is the greatest possible value for the width? Set up an inequality to model the problem and solve. So in this case, there's some background information we need to know. We know it's a rectangle, and we know we're trying to find the perimeter of a rectangle. So if you think about, if you have a rectangle and you're trying to find the perimeter, this would represent the length, the width, the length, and the width. So to find the perimeter, you're adding up all of these lengths. So the perimeter is equal to length plus width plus length plus width. This can be simplified into a similar equation where you have 2 lengths and you're adding that with 2 widths. This is how your inequality equation is going to be modeled. It's going to look similar to this, where we've got 2 times the length and 2 times the width. That's what our perimeter is going to equal. So now going back up to this first sentence, if the length of this rectangle, the length is 6 times the width, that means that this expression here for our length is 6W. So 6 times the width. Same with over here. This length is 6 times the width. So in our initial inequality, if we're trying to calculate the perimeter, instead of L, we can use the similar expression 6W, because 6 times the width, this is what we're using to represent the length. So instead of L, we'd want to set it up as 6W for our length plus 2W for our width. And now it says the perimeter is at most 154. So 154 is what we put in for P. But think about this. If something is at most 154, can my answer be larger than 154? No. So since it's at most 154, that means that's the largest that number can go. It can equal it, but the equation for finding the values can't be greater than 154. So 154, in this case, 154 is greater than the expression, if you write it the other way, this is where that less than comes in. So 2 times 6w plus 2w, this whole expression has to be less than or equal to 54. So note that depending on how you write it out, in both cases, the inequality is opening up to that 154. And just right here, opening up to 154. So the rest of it is just solving the equations like we've been doing. 2 times 6w is 12w, plus 2w is less than or equal to 154. 12w plus 2w is 14w, less than or equal to 154. And then 154 divided by 14, we end up with the width needs to be less than or equal to 11. So what is the greatest possible value for the width? The greatest number that it can equal is 11. It can be less than 11, but the greatest possible value is the width has to be less than or equal to 11. So just another example. Jake started a business selling t-shirts. He spent $3,200 to obtain his merchandise, and it cost him $150 per week for general expenses. He earns $850 per week in sales. Write an inequality to model the problem. So there's different answer choices here, different options. But think about this. If he's spending $3,200 and he's spending $150 per week, these two are both expenses. So these are going to go against money that he has for profit. He's earning, though, $850. So think of this as being a positive $850 that he's earning. Each of these you're subtracting from his profits. So think about those words. Spent and cost means it's something that's costing him money. He's losing money on a profit. Earns is he's increasing money on a profit. So looking at the different answer choices, we want to identify the inequality that shows the money that he's earning is greater than the money that he's spending. And if you want to make money in a business, you want the money that you're earning to be way more than the amount you're spending. So when we're looking at the different inequalities, if this is how much he's earning, this should be more than both of these. Looking at this one has a cost on one side and a cost and an earning on the other. This one would not work. For part B, his earnings, $850 a week, should be greater than his initial expenses and his expenses per week. So this one would actually work because it's showing his earnings being greater than his expenses. You want your earnings more. So then to actually solve this one, to figure out how much he would need at a minimum per week to make a profit, you've got your inequality. Now you just have to collect like terms on one side. So subtracting 150W ends up with 700W is greater than 3,200. And 3,200 divided by 700 that divides out to the weeks would have to be greater than, and it's a decimal, so I'm going to round. So 4.57 is the number of weeks. So what's the minimum number of weeks it'll take him to make a profit? Since we're already into our fourth week and half of week 5, if we're talking in whole weeks, then the weeks would be at 5 weeks. So after 5 weeks, or at the 5-week mark, he's going to start earning a profit. He won't earn it at 4 weeks, and since it's in the middle of the 4th and 5th week, you'd want to round up to be the 5th week. So the weeks would have to be greater than 5. So one last example, this one talking about age. So Janessa is 6 years older than twice her brother Omar's age. The sum of their ages is less than 52. What is the greatest age Omar could be? So if you have trouble setting up equations, just think about this part here. The sum of their ages is less than 52. So that means that Janessa's age plus Omar's age has to be less than 52. So now we can look at setting up an expression for each of them. I know that Janessa is 6 years older than twice her brother Omar's age. So if we use O, well, I don't want to use O because it looks like a 0. I'm going to use A. If we use A for Omar for age, we can use that variable A for Janessa's age. So 6 years older than twice Omar. Well, twice Omar would be 2A, and then 6 years older is plus 6. So here's our inequality. 2A plus 6 plus Omar's age has to be less than 52. Note the two different A's. It's very common for students to see, oh, here's Omar, and they don't have this added A. But this whole expression here, this part just represents Janessa. This represents Omar. You have to have both because you have to use Omar's age to find Janessa's age. So now you can just combine like terms. 2A plus A is 3A plus 6 is less than 52. And if you subtract 6 on both sides, you get 3A is less than 46. And then 46 divided by 3 so dividing by 3, I end up with the age has to be less than 15.33. So since we got a decimal, in ages we're going to be looking at total years. So we would have to say that Omar's age would have to be less than 15. So Omar would have to be less than 15. And then to figure out what Janessa would have to be, if you were to plug that 15 in for A, so 2 times 15 plus 6 is 30 plus 6. Janessa would have to be, the oldest she could be is 36 and have it still be less than 52.